Yeah, this isn't gonna.
What if we pour it into something smaller and then?
Do we have a funnel? Or could I pour it into this beaker?
It's gonna be very cold. Nothing. Let's just pour straight.
I could do my best. However, this will probably
fine.
splash on the table.
That's fine. That's fine.
Should I submerge it?
Yep. Okay, now I'm gonna turn on the power supply. Give it some current. Less than 0.5. Wait,
And then I'll definitely have to pour some more now.
this is the current, right? Wait. This is current. Wait, this is 0.5 amp. It says 0.5 over there already. What's going on? This is only... Oh. Yeah, we gotta plug in the milliamp terminal.
Ah.
Yep. Wait. Too sensitive. Let me try this one. Okay. So less than 500 amps and then...
And then pour a little more in now.
Yeah, more. So as you see now, the temperature reading is increasing. It was 0 before. It's now 6 something, and then pay attention to the magnet too. And
I see why I need closed-toed shoes.
yeah, and why this thing isn't changing? 0.6 volts.
0.06.
0.06, and then if it cools down, it should go to somewhere around 6 volts.
Do they switch?
No, that doesn't matter. And this one, its voltage is always 0.
Should these be on millivolts DC?
This one we don't know. And, could be even if we set it on millivolts, its reading is still wrong.
Do we have the wires right? It is green wires into...
Yep, that one is right. These two, the temperature doesn't drop. Let's give it a little bit more.
What's the opposite of a superconductor?
It's not being super.
That's so cool to watch.
Let's cover it up. And then does that thing? Oh, actually, it floats. It already floats. Is it?
Yeah, it looks like it.
Well,
Yeah.
would it float in the nitrogen or no? I guess...
No, it's heavier than liquid nitrogen. But wait, our meter is wrong. Let's grab a different meter. For voltage. Yeah. Still, well, if it's already superconductor, then that should be right. 0, but why this one doesn't change?
I don't think that's floating yet.
Push it to the center.
Yeah, it's...
Yeah, no, it's on there.
It's sitting on there, or
Yeah, I believe
it's
so.
not floating yet. It
It's
doesn't look
not.
like it.
Oh wait, no, it is
Oh.
floating. It is floating.
And let's try this one for voltage. Why the voltage reading doesn't look right? Wait, this one is in.
Oh yeah, no, it's 6.3.
I tried millivolts, and is it reading table millivolts or volts? Maybe I made a
I think it's
mistake.
millivolts.
Oh, millivolts. Okay. Well, this one it's already superconducting because it's 6 point some volts, 6.33 now. How much is it?
Oh goodness.
6.33. That's 79 Kelvin. Yeah, so that's about the liquid nitrogen temperature. Yeah, it is. It's hovering on top. It is. It is.
Elvis Lab.
It's super.
Some might say it's an amazing conductor.
It's
So
good.
if that's the case, we didn't really see like the before it was a superconductor. It just started at 6.3.
Because that one's
Maybe.
been reading 0 since the beginning.
This one, right?
Yeah.
Yeah.
That's not right. Even if we switch to millivolts, and let's watch this thing warm up and see how voltage changes. Yeah. It's recording, right?
Yeah.
Yeah.
Okay.
That would be sad if it wasn't.
That would be pretty sad.
Yeah.
Yeah, we'll be doing this again.
This is like. Oh, okay. Just curious what it's
Did we record the transition of this thing? No, we got the reading wrong. We need to do another recording too because we set it at volts instead of millivolts.
Yeah.
We only have one digit of reading. We cannot get the detailed temperature. Yeah, we'll do this again.
I think I might just upload all the videos to YouTube and be like, yeah, you guys do it.
Hey, if you make this a YouTube short, it might randomly blow up.
10 YouTube shorts.
Do you guys have your own YouTube channels?
Yeah.
I did. Where I just copied other people's like stuff and tried to get famous off it.
When I was younger, I actually made videos and stuff because I wanted. I still, if I could be a content creator, that's the dream. Play video games all day.
I'm really upset because I used to have like a Minecraft YouTube channel when I was in like 6th grade, and I deleted everything because I was like scared of you know, being weird. And now I'm really upset that I deleted them because I was like, oh, it's perfect content.
I just have recruiting videos. Just trying to recruit
Hey,
for
everyone.
hockey. But
You recruited yourself.
yeah, and then I had a scholarship video where I talked about it was the physics behind skating. So poorly made. It was like the videos I put in there. I was like, yeah, this looks great. And
I
then
know.
when I rewatch, I'm like, yeah, I don't know why.
I would use the YouTube editor and use their like free music on the Sky Wars highlights.
Oh.
I used to have OBS Studios and then OBS Editor,
Yep.
and I tried to use those, and then I
I
got
had
bored of it and then
iMovie.
started Twitch instead. I still wish I
never
could
had
be
good enough
famous.
internet connection to do Twitch.
I still think I have one idea that might work. So,
Just
just might work.
I
I'm
feel
really
like
good
any
at
idea
Guitar
would work
Hero.
if number one you're already famous and number two.
True. It's a lot of luck, I won't lie. But like, I'm good at Clone Hero or Guitar Hero, and I have 1,300 songs on my computer at home. So I'm like, if I start a Twitch stream of like playing every Clone Hero song and going through like,
I feel like that's so much easier said than done.
hey, once I hit like 80% through, and once I'm like getting to the point that I've almost played every song, I'm telling you, make some YouTube shorts, make some TikToks, it's gonna blow up. People are gonna be like, ah, or it won't.
Yeah, or what?
Or it won't. I don't know. I still play Clone Hero all the time, so I mean, might as well. That's
And
actually
then
the
if you
dream.
have like a breakdown during it, where like you mess up or something, then that would be even Yeah.
Just start breaking everything.
Bring a new one.
Do you know Queso?
I do.
I don't watch him, but I've seen what I used to not like him, and then I saw one clip of him that it was like he was talking about being a streamer, and he was like, "It's pure luck that I'm here.
Yeah.
Like I'm just a fat dude that talks on stream, and you guys made this possible. Like this is no skill. I'm just here playing games with people I like all day." And I'm like, "See, that guy gets it. He's not one of those guys that's like, oh no, it's pure skill being here." It's like, nah, you just randomly blew up to become
I would say
famous.
it's
You gotta have like 10-20% skill.
yeah.
Making a good content presentation is actually
with
pretty
YouTube-
challenging.
I think with YouTube, there's definitely more skill involved.
Yeah.
I think.
But now you
YouTube more so.
come around. Let's take a look at the magnet. This time without liquid, it's easier to see it hovers in there.
It's actually so cool.
I was literally just about to take a picture of it, but
You can do a video of it.
that is so cool. So now in order to
So we want to see when it drops. Right? That's when it transitions back into a normal conductor.
Oh, that got a little cool.
And temperature reading is slowly increasing. Right now, 6.24. That's about 81 Kelvin.
That's actually, wait, I gotta get a picture of that. You can see the gas just like overflowing over the top.
Oh, that is so cool. Whoops.
But yeah, I feel like Twitch, I don't know. There are a lot of people that just sit on camera and like literally say nothing all stream but still have like thousands of viewers.
I really like 3 Blue 1 Brown.
Oh, I love that guy. Him and Veritasium are my
Yeah,
favorites.
I watch all their content. And then there's other like computer and electrical engineer people that I really like.
But for those who are gamer, and the how long can they develop that as a career? Because when you get into a 30s, probably you're not a good gamer anymore, right?
There are some people that like make content off of actually being good at the games, and then there's some people that are funny and are horrible at every game they play, but people still watch them just because they're funny.
Okay.
I like to imagine I'm funny, but I don't know if thousands upon thousands of people would agree with me. But I game all the time anyways, so someday I'll just start streaming because it takes no effort, and then maybe I'll blow up.
So basically, when you do the gaming show in your computer, just stream your gameplay.
Mm-hmm.
Okay.
So what most people do nowadays is they have like one monitor where they just play their game, a camera that they put on like a corner of the screen so they can see their reaction, and then they just have another monitor for Twitch chat and the actual
To
like, live
interact with
streaming
the
and
fans.
everything. Yeah.
Okay. But for those that are really intensive action games, then how can you stop in the middle to interact?
I don't understand it either. That's
I
the
feel like you just don't.
yeah. Some people are a lot better at multitasking than others, but it's still floating a little bit.
Yeah, still.
I can't even walk and
The voltage is still 0 at this point. 604. Temperature 604. Let's take a look. 604, that's about 86 Kelvin. Oh, 5.8. It's increasing pretty quick.
It's still floating a little bit.
Voltage, if it's measured correctly, right now it's still 0. That's suspicious. Let's see.
I'm a little suspicious of that.
5 point something already. This is a 90 some gram. 90.
Still.
Yeah, this is in the range of 90s.
Oh.
Well, let's see if the temperature actually. Right now it's not technically not 0. Oh,
Oh,
looks like it's increasing.
that looks like it's staying at
And still
Oh,
Still barely floating. Its corner is about to touch.
Yep.
Oh, is it? On the
Now 0.9 now. Okay, it's quickly increasing the voltage.
Yeah.
There we go.
Yeah.
It's
Okay.
fallen.
so.
So this is a correct reading. It is correct. 0.4.
Okay. So it's a superconductor. Okay.
And it's not completely. Surface probably is already not. Core still is. Yeah.
Is this like a magnet where even when it's like a superconductor and it's lifting above, where I can like push down and make it, or is it like?
And sometimes when you apply a magnet too strong, right, it's already cooled down superconductor.
And that's
But
its
when you
unibrow.
force a very strong magnet on it, and the thing will actually transition back into normal,
Okay.
not a superconductor anymore. When you have a field that's strong enough to force on it. Is it levitated or not?
Nah, it's fallen. It fell a little bit
486.
ago.
486, this is about 110. Okay, this is already made in.
Yeah,
No,
it
no.
fell, I think, around 86. I
All
said it
materials.
out loud so we can find it.
Okay. Well, once the temperature reaches a little bit higher, we can pour liquid nitrogen back in to record the cooling transition. And later on, when you extract data, right, and you want to have more samplings when it makes the transition, so you can see how it plummets. And when it's slowly decreasing that part, you can probably skip a few seconds, make a reading. But during the transition, you don't want to skip too much. Right?
The frost around the table is funny too.
4 something. This is 120. Yeah, once it reaches about 140, we can start the cooling transition again.
Alrighty.
140 is about 4.11 volts.
Is this? I probably. I was really gonna see if I could drop it from here, but I feel like that would be bad for the magnet.
And some magnet depends, and when you shake it, and it can lose its magnetism. Some material, some iron based.
I
When,
just
when it's
wanted-
under a huge impact, it can lose.
Yeah.
Because for magnetic material, those are iron based, and inside the material there are some small zones. Sometimes people call it domains. Every single one is magnetic. When you have all of them lined up in the same direction, then all their magnetic field add up. It behaves like a magnet. But when you drop it, you shake it, those things shake to random orientation. Then that's why it loses its magnetism.
Do you watch much YouTube?
YouTube?
Yeah.
Every day I go onto YouTube, and during the weekend I watch some soccer play highlights.
Oh.
And the Premier League is coming to the end, and the German, what do they call that? Bangladesh or something?
Oh.
Something, yeah. And then I was watching those highlights during the weekend, and the other time every day I go onto YouTube watching various things, and yeah.
I was gonna recommend Veritasium if you've heard of him before.
Well, what's the content of that?
It's all science.
Okay.
He pretty much, it's like random science questions, mostly physics based, I think.
Okay.
There was one that I watched recently that reminded me of you because of our optics class, where he was talking about light and about, I can't do the whole video because it was like 20 something minutes long, but it was about how light actually travels like every possible path that it
Yeah.
can.
Oh yeah.
But it's because of its action that it takes the least possible path, because it will have a random phase difference essentially, because you take like the amount of time that's passed divided by the Planck constant to find like its new phase difference. And if you add up the phase difference from every path it's traveled, it's essentially random and they all cancel each other out except for the path of least action. And I was like, oh, this is
The experiment that he showed where like, it was like, he had a mirror, laser, and then the laser would come back up to the mirror.
Or the camera.
Was the
mirror
shortest
like-
path.
Yeah, the
Shortest
camera.
of time,
Mhm. And then what the person did is he just put like something on top.
It was a special optical sheet that he
I'll just pull up
put.
the video.
Yeah, he had a laser at 45 degrees and a camera, and then he put a special optical sheet over it. I'm not sure exactly what it was, but instead of shining on the sheet and coming up to the camera, it went like straight down and bounced this way because that became the new path of least
Shortest,
action.
least action. Okay.
I feel like it would just be easier just to show you.
Oh, okay.
And see where they line up. And so if I turn on this light, that's exactly where you see it reflect. So that the
This
angle
honestly,
incidence is
it kind of blew my
equal to
mind
the angle of
when I
reflection.
first saw it. I
Yeah,
was like,
this presentation is made this way is
Cover up that spot so that we no longer see the light reflect.
help you visualize the path, and then that's
Yeah.
really
We're gonna
good.
prove that 5 minutes, right? That really light also goes like this. It's just that most of the time those effects are canceled out. Now that sounds impossible, right? But let's zoom into this tiny piece right here. Then we see all these different paths, and all the arrows just go around and around in circles. So when you add them up, they all just cancel out. But what if I cover up about half of them, like so? Well, now when I add up those arrows, you suddenly do see a large resulting arrow. And so if I can somehow cover up this mirror in many, many tiny strips, then I should be able to get the light to reflect like this. And I can do that with this piece of foil right here. On this piece of foil, there are about 1,000
the
lines
3 blue,
per
1
millimeter,
brown,
and
where it was
should
like
be able to
holograms,
get
how they work.
So
I haven't
let
seen
me
that one.
turn off the lights. So let's
Way beyond my pay grade. I was watching it and I watched it like 4 or 5 times and I was like,
We see it. We see it. Ah, that is so cool. It actually looks a lot weirder than I was expecting it to. I was expecting more like one spot.
This is not a
There's
laser,
very
right?
many spots.
No, it's
No.
not. I was mistaken
Yeah.
there.
Ooh, okay. Yeah, and just to show I haven't been cheating you, right underneath is my finger. And even with the light on, you know, we see the light reflect.
So it has a
And if
camera
we
underneath
remove
the glass.
cover.
No, it's
Yeah.
what do we
up
see?
there.
yeah.
Oh, okay. Wait, this is from
See
looking from.
exactly the normal reflection.
Yeah, so it's coming, the normal reflection is off the mirror to the camera up here, and then when he covers it up and puts the foil on, it goes straight down to the foil and bounces up to the camera.
I was trying to convince Schneider
Very, very
to
cool.
look up
When
3
I was
blue,
talking
1
about
brown.
it with a friend, actually,
And I don't know if
he
he
said,
did,
yeah,
because I was
because
like,
the
oh my
refraction
goodness, I
rate,
feel like
that's
you
kinda
would,
like cheating,
you would
because
love
you get
it.
all these other reflections right now. And this
The
light
3 blue,
is
1 brown's
going
more
in
like
all
pure
directions.
math.
And so there's one
Yeah,
other
but
then-
that one's a
I've
lot
been
more math
Yeah.
intensive.
super
Veritasium's
about.
surprisingly math
I
intensive
also-
too for how
Yeah,
popular he is.
the only,
where
I know
should
that for
right
the
next to it,
video
and
he
then
did like
it does
about
take every
electricity
possible path.
and
We
how
should
it
also
actually
see
works,
It probably
uh,
shouldn't work.
a lot
Actually,
of
the laser
electrical
right over
engineers
here,
had a very big bone
and
to
we can
pick with
see
that one.
Oh, yeah,
I was
he
not
did do
smart
it
enough
with
to
the
know
laser.
why he was
really
wrong,
does just
but
go to one
these people
spot. You
apparently
can see
were.
where that spot is. It's right over there, which is about the same place where we had our reflection. And you can also see right now, we look at this view, that you cannot see the laser light at all, right? Like I could.
I wonder
see
how
the
long
laser
my
light
phone
bring it
records
down
for.
all the way over here.
I'm at 25 minutes right now.
If I
We can pause it now and then.
Yeah.
Or,
the
Um,